Hello everyone. So we're on our last set of notes for Unit 5. This is Global Climate Notes Part 3. We're going to be doing two objectives, 2.6.2b. I'll explain the concept of the greenhouse effect and list specific greenhouse gases and why CO2 is the most often the focus of public discussion. And then I will explain the next one. So global warming. Global warming is all life on Earth depends, of course, conditions on the temperature and rainfall, right? And so again, just as you to remember is that, again, temperature and rainfall. That is what climate depends on. Okay, that's a review. Our planet is getting warmer. The 2000s was the warmest right now, so what we're living in has been the warmest ever recorded. And this is because of global warming, because this is the average temperature of Earth has increased. This is just again to show you over the years we have ups and downs, but as you see here, we have gradually went up recently within the 2001. We have a lot of things that have incorporated with that. So we have cars, we have buildings. Back in these days, in the year 15, you know, they didn't have half of the technology that we have. They didn't have cars. They didn't have big old factories and stuff all over the place. They didn't have all those big airplanes. So what happened is that as technology increased, especially here, internet and everything came in this era, a lot of things increased too. So this is causing the climate to misbehave because it's something that is unusual. So please remember the greenhouse effect. That's the key word. The greenhouse effect is a natural warming of both Earth's lower atmosphere and the Earth's surface from the solar radiation. So as you see here, reflected, and as well as what's being to the surface, also what's being reflected back into the atmosphere. So again, the greenhouse effect is the natural warming of both Earth's lower atmosphere and the Earth's surface from solar radiation being absorbed as well as being emitted by the atmosphere. So of course, what is the biggest hypothesis that's been accepted? Again, it has to do with human activities that add carbon dioxide into the atmosphere and other greenhouse things to the atmosphere. So as you see here, greenhouse gases, you must know these four: water vapor, methane, nitrous oxide, and fluorinated gases. Okay, so our biggest one, of course, water vapor, methane, and as you see here, we have the CFCs, we have deforestation, we have oils, we have all these things, and these are what we're going to be talking about today. So something to ponder upon. What do you think? So this says sources of global greenhouse gas emissions. A lot of it, as you see here, is energy supply. We have to have, you know, honestly, you have to have lights and stuff, right? So we actually have, we talked about it before, we have different nuclear plants, and we also have different coal factories that does supply our energy. Transportation is 13%, but industry, so the manufacturers, all those big businesses that makes all these things, is 19%. Forestry, we cut down a lot of trees. Agriculture, we do a lot of different things, and the farming and stuff. So these are different things to think about for our sources of greenhouse gas emissions. I may ask you a question, which one would be the most or possibly the least effect? Global warming, again, is burning of fossil fuels, cutting and burning of forests. And what does that have to do with that? We learned these before. So fossil fuels and deforestation. What happens is it adds carbon dioxide instead of removing it, and we need to have it removed because of the carbon cycle. This causes heat from the sun to be trapped in the air instead of bounce back in space. So that's what ends up making the earth warmer. So the more carbon dioxide we get into here and it's trapped, it makes that heat come back to us because it doesn't know how to separate itself. So why do we focus on carbon dioxide so much? Well, because we breathe out carbon dioxide, right? If we keep cutting down the trees, what's going to inhale or ingest and take in the carbon dioxide? Nothing. So we actually emit more than any other greenhouse gas. And so a lot of them, just that they may be trapped, like methane, they're also harder to control. So as you see here, carbon dioxide, methane is 10%. Methane can come out as well as in multiple ways. Nitrous oxide, look at the percentages. So carbon dioxide is a big key focus. So think about how you can reduce this by looking. So here's again carbon dioxide. Most of this is released by our electricity and transportation. Here, nitrous oxide, agriculture, methane has been, look at these numbers, the gas that we have, and fermentation. And then this one says just overall, look at this. Substitution of ozone depleting substances, 91% by fluorinated gas emissions. So this right here plays a big factor. So these are things you need to look at. These are the four main things. So carbon dioxide, nitrous, methane, and fluorinated gases. So now we're on our next objective. This is 2.63b and explains how large-scale development contributes to regional changes in climates. So this is also going to talk about the greenhouse effect, heat islands, as well as it's going to talk about things like the global warming. So explain what this picture shows and improve your definition of heat island. So what this isn't for me to really just explain off the bat, but you can tell that here, if this is late afternoon temperature, right? Why does it seem to rise over a town? What's going on in the city? It's always moving, right? So we always have cars going. We got buildings. We got factories. We got people that's there. There's no trees in the area. You see limited trees. So what is there to actually catch the carbon dioxide? What is there to catch the bad gases? Nothing, because it's open. And so it goes back to the atmosphere, which causes a heating, which we just understand that was called something global warming. So the term heat island refers to urban air. And surface temperatures that are higher than rural areas, okay? So this is a key term. Please know this for your assessment. So now, what factors can you think about that as a heat island? I just told you, if it's urban and it's reducing from something, what is missing? Again, trees. There's no trees here. There's a lot of high activity here. So those are the type of factors that can cause this, correct? So these right here are just, you understand how these factors work to promote a heat island. Concrete and man-made surfaces, right? Surfaces, these things are not benefiting us. It benefits us by what we have, but it doesn't benefit our atmosphere. Less water in the soil, is that good? Less water in the environment, is that good? And we have all this energy being released from these buildings. Is that good? No, but now can you tell me how that promotes a factor inside the heat island? So I want you to take a time to ponder and review that, because how can this really right here actually make a very big impact to us now? So heat islands, the principal reason for the nighttime warming is the building block surface heat from radiating the relatively cold night sky. So the principal reason of nighttime warming, because sometimes it's hot, especially during the summer, we'll be having some hot nights. The sun ain't out. And it's because, again, the buildings that block surfaces from radiating into the cold night sky. Now, when you are in certain areas, you can feel the temperature decrease immediately. There's nothing blocking that coolness coming. So what happens is that tar, asphalt, brick, and concrete absorbs insulation, and it releases as heat. Dirt, we talked about this before, dirt can come in and it actually allows things to cool. So if you have a lot more buildings around you, it blocks the cool air for sinking in, but it actually increases the heat to actually, and then it says rather than reflecting it without heat like soil does. So what happens, it reflects the heat, and the heat stays there because of the buildings and because of the tar. But the more trees, the more natural things you have, you will have a cooler night. So rural versus the urban. During the day in rural areas, the solar energy absorbed into the ground evaporates water and vegetation, thus causes evaporating cooling. In cities, we have less vegetation, so we don't have, and again, that is less plants, less trees. The buildings and streets and sidewalks absorb the majority of solar energy put. So what happens, all that heat is being transferred. And if you notice, a lot of buildings and stuff are darker colors because of the concrete, because of the tar, because of the roads. Everything about that is dark, and dark basically, again, absorbs heat and it doesn't reflect it. So once it absorbs it, the heat does radiate from it. Instead of cooling things down, it stays hot. That's why during the summertime you can touch the road and it's super hot and it can burn your hands. People even fried eggs on it. So that's one reason why when we were in grass and stuff, that's evaporative cooling. It automatically cools. So forests, we know it's important. So I don't have to go into details with this, but you know, it gives us protection from erosion, it gives us oxygen, it takes away carbon dioxide, it helps control climate. If you're around a lot of trees, you see a very steady temperature, and you don't really see that much fluctuation. Forests also are vital because they give food, shelter, medicines, and everything. Now, we already talked about this before. Some of you already did a project on this. Deforestation is an important factor in global climate change. Why? What did we talk earlier? It talked about CO2. If trees decrease the amount of CO2 in the atmosphere, that gets caught up. But if we keep cutting them down and building things, then we are going to increase CO2, which does change and impact our climate. So again, it's estimated that 1.5 billion tons of carbon dioxide are released into the atmosphere due to deforestation, mainly the cutting and burning of trees. That is crazy. Our forest helps keep the carbon cycle balanced, but see, when we burn it, we're releasing more carbon dioxide in the thing, because what happens in the gas? When we start a fire, what is being released? So then also imagine what is being intaked. So we may inhale it and stuff. Are you supposed to be around a big old bunch of smoke? No, because if you inhale so much because of the gases that are in there, it begins to damage us. So what do you think when the atmosphere is inhaling that same smoke? So again, the carbon cycle is something that plays a big role in our planet. We know this is for the key word, photosynthesis. It goes back for photosynthesis to occur, as well as it goes back for cellular respiration to occur. Cellular respiration is us. That's where it goes to. When forests are cut down, not only does carbon absorption kind of decrease, but this also allows the carbon stored in the trees to be released into the atmosphere as CO2, as if the wood is burned, because there's nowhere else. It's too much. They have too much. If you have too much water, you try to, or something too much in your mouth to drink, you're eventually probably going to spit it out because it's too much for you to swallow at one time. So what happens is the same thing with them. These trees, it's too much CO2 to swallow at one time, so I'm going to spit it back in the atmosphere. Now something else isn't catching it. So every year, more than 15 million hectares of tropical forests in the state of New York now are cut down. Think about it. Me personally, I didn't think New York even had any trees left, but that's really why, because 15 million hectares of tropical forests are cut down, releasing over 1 billion tons of carbon. So that's one reason why you go to New York, that air is not as clean as North Carolina's air, because they take a lot and made everything urbanized. So many of the world's tropical forests will be lost by the end of this century. Okay, come on, we already at 2020. Centuries are not that long. So with the forest, we will lose important species. We will lose different things, and we will slow down the climate change. It's going to increase, because we actually, as the opportunity to slow climate change, we don't get to slow it down. We're going to speed it up. So Bible Technical, please understand that deforestation is not right, because we, again, are fighting climate change because of that, because of the levels of CO2. So burning fossil fuels, you know, it's not good. I'm not going to go into details about that, but you know, you can read this slide. Coal, oil, natural gases are 3 ways that are widely used. So again, remember those 3 terms: coal, oil, and natural gas. So petroleum is used for vehicles, while coal and natural gas are used for electricity in our homes and office. Greenhouse effect, and we already seen this picture earlier, but this is again just a reflection. But again, please know the greenhouse effect is the presence of carbon dioxide in the atmosphere, which makes our planet much warmer than the moon and other planets around us, because we have heat that is trapped from the sunlight and does not go beyond the atmosphere. So greenhouse effect, again, burning fossil fuels. Man, we gotta slow down with some of that, because we increase, again, CO2. And I want you to remember that, because it's going to be part of your assessment. When there is a significant rise in percentage of carbon dioxide, the amount of heat captured of carbon dioxide gas also increases. So again, we told you earlier, this is called global warming. So when you does that, it increases the temperature. That's called global warming. Combustion of fossil fuels not only give out carbon dioxide into the air, but it releases various types of carbon, methane. Again, we already talked about this. This does not look good. Now, for those, again, I tell you all the time, smoking is not good for you. I don't care what you smoke, and I don't care what your reason is for it. It's not good for you. If the atmosphere is inhaling this and our atmosphere is dying, what do you think this looks like when you're inhaling into your lungs? All right, I want you to think about it. But of course, when we have deforestation, we have industrialization, and we already understand this is also known as urbanization. And this is again where a social economic change from transform a human group from an agriculture base into an industrial one. So we basically again take it from being soil to making it buildings. How is this linked with deforestation and global warming and climate and heat islands? Well, what happens is that all those buildings that we cut down, all the streets we cut down and build those buildings, again, the factories come here. Stuff is made from factories. Factories are burning off fossil fuels, and then that's going to give us less trees, and then when the trees is less, there's more carbon in the atmosphere, so that causes that area and to rise, and that's what we call a heat island. So again, the effects of heat islands can raise temperatures in cities 1 to 10 degrees Fahrenheit over the surrounding areas. If you ever looked at the news, you would realize some areas here in North Carolina have higher temperatures than other parts, not because of just where we're located, it's but because of some is more urban than others. Air conditioning costs increase because why? If the hotter it is, you got to run your AC, and that electricity is running more. So then we're putting more carbon dioxide in the atmosphere. So it's a never-ending cycle. Air pollution increases, health related illnesses happen. Look at corona and stuff. Some of this is not just happening just because someone had a bad flu symptom. This is coming with all the stuff in the atmosphere. But now, if you notice too, they even said the earth has been the most cleanest as it's been in years, and hopefully this stops some of the rate of global warming. So again, the next time you go out there, just think about these things. And so remember, the way that the heat island works effect is that, again, it affects the whole temperature of that city. Pretty much very similar to the greenhouse effect, but both it raises nighttime temperatures and it releases by slowing the release of heat. So all of that is taken in, because back in the day, night temperatures in Phoenix are 7 to 13 degrees warmer than it was in 1970. To you, that doesn't seem like a lot, but imagine if your summer was usually 90 degrees and your next summer was 113 degrees. That's a big difference when you feel the temperatures. Think about an oven. 250 degrees feels a lot different than a 400-degree oven.